How does your car's air conditioning system keep you cool on those scorching hot days? Let's take a closer look at how the car AC works. The car AC system operates on the principles of thermodynamics and fluid mechanics. It consists of several key components working together to cool the air inside your vehicle. First, we will see the locations of all components and after that their functions. The first one is the compressor. It is mounted on the engine block, usually at the front of the engine block, or mounted on brackets attached to the engine, near the radiator and condenser. Condenser coil, located in front of the vehicle's radiator, near the front grille. Receiver dryer, located between the condenser and the expansion valve, often near the condenser. Expansion valve, typically located near the firewall, close to where the refrigerant lines enter the cabin. Evaporator coil, inside the vehicle's cabin, typically behind the dashboard. It is housed within the HVAC unit, that is heating, ventilation, and air conditioning unit. And blower motor fan, it is also located inside the vehicle's cabin, usually within the HVAC unit, near the evaporator. And the refrigerant gas is a specialized fluid that is used to circulate inside the air conditioning system. Let's see how it functions together. When the AC is turned on, the climate control unit sends a signal to engage the AC compressor clutch. The compressor is typically belt-driven, meaning it is connected to the engine's crankshaft pulley via a belt. As the engine runs, it drives the compressor, providing the mechanical energy necessary to compress the refrigerant gas. The compressor consists of one or more pistons housed inside cylinders, which compresses the refrigerant gas. The refrigerant initially enters the compressor as a low-pressure gas. This gaseous refrigerant is then compressed by the compressor, which increases its pressure and temperature significantly. After being compressed by the compressor, the refrigerant gas exits the compressor as a high-pressure, high-temperature gas. This hot gas flows into the inlet of the condenser, which is usually located at the front of the vehicle, near the radiator to take advantage of the airflow when the car is moving. The condenser is made up of a series of tubes and fins that provide a large surface area for heat exchange. As the hot refrigerant gas from the compressor flows through the condenser coils, it releases heat to the surrounding air. The condenser fan and vehicle motion ensure that sufficient air passes over the condenser to dissipate heat effectively, enhancing the cooling process. As the refrigerant loses heat, it begins to change from a high-pressure gas to a high-pressure liquid. This is called phase change. This phase change occurs because the refrigerant's temperature drops below its condensation point as it releases heat. The cold refrigerant is now cycled back through the receiver dryer. The receiver dryer helps separate any remaining gas from the liquid refrigerant. The internal structure of the receiver dryer facilitates this separation, ensuring that only liquid refrigerant flows to the expansion valve. The filtered, moisture-free, and high-pressure liquid refrigerant exits the receiver dryer and flows towards the expansion valve. The expansion valve is a vital component in a car's air conditioning system, responsible for regulating the flow of refrigerant from the high-pressure side to the low-pressure side of the system. When the high-pressure liquid refrigerant passes through the expansion valve, it encounters a sudden drop in pressure. This pressure drop causes a further drop in temperature, leading to a partial phase change of the refrigerant from liquid to vapor. The refrigerant exits the expansion valve as a mixture of liquid and vapor and enters the evaporator. The evaporator is typically located inside the HVAC unit behind the dashboard, and it is typically made of aluminum or copper. These coils contain the refrigerant that absorbs heat from the air. Fins attached to the evaporator coils increase the surface area for improved heat transfer. The evaporator coils are cold because the refrigerant inside them has undergone a phase change from a high-pressure liquid to a low-pressure gas, causing a total drop in temperature. Now warm cabin air from the interior of the vehicle is drawn into the HVAC unit by the blower fan. As the warm cabin air passes over the evaporator coils, the refrigerant inside the coils absorbs heat from the air and makes it cooler. Then now cooled air is blown out of the HVAC unit by the blower fan and circulated into the vehicle's cabin through the air vents. Air vents distribute the cooled air throughout the vehicle's cabin, providing a comfortable environment for the occupants. In addition to cooling the air, the evaporator also plays a role in dehumidifying it. As warm air passes over the cold evaporator coils, moisture in the air condenses on the coils, forming water droplets. These water droplets are collected and drained out of the vehicle, reducing the humidity level inside the cabin and improving comfort. It ensures a comfortable, cool, and pleasant environment for the vehicle's occupants. Now let's talk about the AC cabin air filter and the recycle button. These components play a crucial role in ensuring you have clean air and a comfortable environment inside your vehicle. Here's how it works. When the recycle button is off, the system draws fresh air from outside. This helps to ventilate the cabin and reduce stuffiness. Fresh air can also help clear foggy windows more effectively, especially in humid conditions. When the recycle button is activated, the car's HVAC system stops the flow of air from outside and recirculates the air already inside the cabin. By recirculating the already cooled air, the AC system can cool the cabin more quickly and efficiently. Recirculation mode or fresh air mode, the air should be filtered. For this, an air filter is used. The AC cabin air filter is typically located behind the glove compartment or under the dashboard on the passenger side of the vehicle. When you turn on your car's AC, air is drawn from outside or recirculated from inside the cabin. This air passes through the cabin air filter, which captures contaminants and provides cleaner air. The filtered air is then distributed through the vents, ensuring you breathe clean air while driving. The refrigerant, now in gaseous form, exits the evaporator and flows to the compressor again. The compressor receives the low-pressure gas, compresses it, and again sends it to the condenser, and the process repeats. The cycle continues as long as the AC system is turned on and the blower fan is operating. With the evaporator absorbing heat from the cabin air, the condenser releasing heat to the outside air, and the expansion valve controlling the refrigerant flow between the two. This continuous cycle allows the AC system to maintain a comfortable cabin temperature and humidity level while the vehicle is in operation. But how does the AC compressor work in an EV? Let's look at how things are done in electric vehicles. In EVs, the AC compressor is powered by an electric motor. This motor is driven by the vehicle's high-voltage battery system. Electric compressors have fewer moving parts and do not rely on belts, which can reduce maintenance needs and improve reliability. In summary, while both IC and EV AC compressors achieve the same goal of cooling the vehicle's interior. We hope this explanation has given you a better understanding of how your vehicle's AC keeps you cool and comfortable, even on the hottest days. Don't forget to like, share, and subscribe for more informative videos. Stay cool and drive safe.